8th grade 1.3 variables and expressions. This is page 13 in your book. So if you want to turn to page 13, we'll get going. And I don't ever have my pin ready, it seems like. Doesn't ever work right, seems for me anyway. Operator error, I'm sure. Variable. First off, our vocabulary is a variable. A variable, they say in the book, is a symbol. Okay, usually it's a letter. And that letter represents one or more numbers. Okay, that's a variable. A variable expression is numbers, variables, and operations. So I'll just give you an example. 1x plus 6. It's got a number, it's got a variable, and it's got some operations. So we'll do more with that as we go through 1.3. So let's see what this has in store for us to do. Example 1, using a variable expression. It says you are riding in a hot air balloon. After traveling 5 miles, the balloon speed changes to 6 miles per hour. So the total distance traveled is the original distance plus the speed times the time, which is 5 plus 6t. So you had 5 miles, your original distance, and the balloon speed changes to 6 miles per hour, where t is the number of hours traveled at 6 miles per hour. Okay? So, the question, they give us all that. The question is then, substitute in for t the number of hours. It says, what is the total distance you travel if the balloon moves at this speed for 1 hour or for 2 hours? So let's substitute those values in. So you'll see we put in 1 hour. We substituted in for the t, which is right here. We put it in for that, and we just evaluate it. And we evaluate it, we use the order of operations. We multiply first, and then we add, and that would be 11. We do the same thing with the 2 hours. Remember, they gave us this expression. We didn't have to write the expression. They gave us this expression, and all we did was figure out what to put in for t. And they told us that too. So this one's going to be 5 plus 6 times 2 this time. Multiply before you add, you get 12. 12 plus 5 is 17. So if the balloon travels at 6 miles an hour for 1 hour, you travel 11 miles. For 2 hours, you would travel 17 miles. So what if, use the information above about hot air balloons. What if you travel 6 miles per hour for 3 hours? What is your total distance? So our total distance, if we're traveling using the information about the hot air balloon above, we have that 5 plus 6t. So we are going to go 5 plus, we put in 3 for t, 6 times 3. We're going for 3 hours at 6 miles an hour. That becomes 18. 18 plus 5 is 23. I almost wrote 5 right there. Let's see if they give us the answer. Travel, substituted in, so we got the 3, we substituted it in, we got 23. Good show. What if we travel 6 miles per hour for a half an hour? What's the total distance? Same deal. We're going to go 5 plus 6 times t. No big deal on the fraction. 5 plus 6 times a half. Okay, we take half, and when you use the word of, what's half of 6, which is 3? My pen's acting up again. Half of 6 is 3, which then would be, I don't know what I do to make that happen. Would be 8. So, anyway, bad writing, but let's see how they do the solution. There's all those steps. Remember, it's what we're doing. I'm just not writing every. They put in 0.5. I left it as a half, but we still came up with 8 as our answer. What if you travel at 3 miles per hour for 2 hours? What is the total distance? So we're trying to mess with this a little bit right here. We still use that. Here's the original. But that's if we were going 6 miles an hour. They want us to go 3 miles an hour. So it's going to be 5 plus 3 times 2 this time, which is 6. And 5 plus 6 in this case is 11. Let's see if that's what they come up with. They're trying to mess with us on that one. Let's see if that. So they give us the same thing. This one right here, look, they made a mistake. Right here, that should be a 3. We fixed it, but it looks like they put a 3 in instead. Came out to be 11. All right, example 2, evaluating variable expressions, and this is at the top of page 14 in your book. Evaluating variable expressions are going to give you an expression with some missing letters, with some variables in them. And we have to put in what those variables stand for. Now it's given, look up here in the top, it's given information. We're not pulling it out of the hat or wondering where it's coming from. Right up here, when x is 8 and y is 2. So here is 3x plus 5y, so we put the numbers in the right place. Now remember, when numbers are written, when it's written like this, 3x, that means 3 times x. And since we're dealing with variables now, we want to not use an x for the times. We should use a dot, or we should use parentheses, and I'll use them in a variety of ways. We'll use parentheses this time. 3 times 8 minus 5 times 2. And probably the biggest thing is to remember to substitute the numbers into the correct places. 3 times 8 using an order of operations, I have to multiply before I can subtract. 5 times 2 is 10. That answers 14. Let's see how we came out on that one. I think we did good. We did. Look at that. Our answer is 14. Okay, this one, we're going to put the numbers in the parentheses. So notice right here, I'm going to go 5. You're writing these with me. X is 8 plus y is 2. Parentheses I do first because of order of operations, so it's going to be 5 times 10, which is 50. Check that out. Comes out to be 50. Okay, translating verbal phrases. Verbal phrase means we have something written with words. The sum of a number and 9. So we're going to take it from words and we need to switch it to an expression. So the number is unknown, so we're going to use a variable, and in this case they're using n. Unless they tell you, it doesn't really matter which one that you use, so we would do n plus 9. Now let's talk about words here. This right here, sum, remember, that's addition. Difference, that's subtraction. So the difference of a number and 21 would be like x minus 21. Difference, you just do it in the order. Okay? Let's see what, and they could have used a different letter, I don't know what they used. N minus 21. The product of 6 and a number, product means, there's the key word right there. Product means to multiply. Okay? That comes out to be 6n. Remember, you don't have to put anything in between a letter and a number to show multiplication. The quotient, that's division of 48 and a number, so you can write that 48 divided by n, or I want you to get used to seeing them as fractions because we're going to be doing a lot of solving, and it's just, to me, it's just a little bit easier to see it as a fraction than written out with the division sign. Okay, now a third of a number. When you take half of a number, you divide it by 2. So if you take a third of a number, you would divide it by 3, or multiply it by a third. Third of, you take 1/3 times n, or you can just take n divided by 3. Third of something, you split it into 3 equal parts. If you take a fourth of something, you would split it into 4 equal parts. So that's dividing. So all of those words are very important. You have to understand what they mean as far as multiplying, dividing, that type of stuff. I want to draw your attention to page 14. There's a box about middle of the page that has some important words for addition. Just real quick, I'm going to put it on this page right here, and I want you to add these to your notes. Addition. What are some words that mean to add? Plus, the sum of, okay, increased by, These are all words that if you're reading a story problem or you're doing a problem total, okay, more than and added to. Okay, those are just some. There's a bunch of them that mean addition. Then you have subtraction. Okay, subtraction is minus. Okay, the difference of. You have decreased by. When you decrease something, you subtract it. Fewer than. And these are right in your book. Less than. Takes you a while to write them down. You can just stop the podcast and write them down. And subtracted from. And those are subtraction. Multiplication. Teeth. I need to practice my cursive. That's terrible. Sorry. Times. Product. Product of. Multiplied by. Of usually means 99% of the time twice. You take twice, that means to multiply by 2. Okay. And last but not least is division. Put it up here. Divided by. The quotient of. Separate. Let's see. Stop. To equal parts. Okay, so those are just a few of all of words that mean added. I'm thinking in subtraction like take away, multiplication. A lot of times it will say the product of. You'll see that one pretty often. Total, increase, altogether is another one for addition. So you'll see lots of them. So take the time to write those and understand those words. So let's do some guided practice ones. It says, here, let me get rid of the stuff. Okay, evaluate the expression when A is 12 and B is 3. So 9A, well, we look up here, A is 12, so we put a 12 in, it's going to be 9, I'm going to use a dot this time, times 12, which is 108. I think that's right. Multiply 108, yep. Okay, AB, that's A times B, whatever A and B are. Up there at the top, A is 12 times B, which is 3, and 12 times 3 is 36. That's good. Okay. Evaluate the expression again. We're still doing these, so I'm just going to put these numbers in. B is 3 times 12 minus 6. There's my parentheses following order of operations. 3 times 12 minus 6 is 6. And 3 times 6 is 18. So let's see what happens there. Knowing my facts goes pretty quick. And we get 18. Very good. Do again. So let's substitute in everything we know. 6 times A, 6 times 12 over A minus B, 12 minus 3. So 6 times 12 is 72. And 12 minus 3 is 9, and 9 goes into 72 8 times. Well, let's see if that's 8. So it's just a matter of substituting the numbers into the correct place, then doing the correct order of operations to get the correct answer. And I get 8. Got it right. Write the phrase as a variable expression using x. So verbal phrase, a number increased by 15, they want us to use x. Increased by, if you remember the list, means to add. So x plus Or we could do 15 plus x because there's the commutative property of addition, so it doesn't matter the order in an addition problem. 8 times the number, so 8x. So it wants us to use x. And we could have used parentheses, or we could have used a dot, but it's just kind of, we don't really need to on that one. All right, so we go example number 4, which says heart rate, writing and evaluating an expression. To measure your heart rate, count the number of heartbeats n in 15 seconds. Then multiply by 4 to find your heart rate in beats per minute. So 15 seconds, there's 4 15 seconds in a minute, so that's why we're taking it times 4. So we have to use n, we're supposed to use n. Oh, there we have it, sorry, I was reading it to you guys. Multiply by 4. So use n to write the expression, so I'm going to do 4n to write the expression, I believe. Let's see what they say. After exercising, you count 24 beats in 15 seconds, then I'll find your heart rate. So I'm supposed to multiply it by 4, so 4n. So I'm going to take 24 times 4, which is 96. So my heart would be 96 beats per minute, if that's what for my heart rate. Okay, so our guided practice savings, you have $25 saved. You save $4 more per week for n weeks. Write and evaluate an expression for your total savings after 8 weeks. So it wants our total, so that's going to include the 25. We saved $4 per week for n weeks. So 4 per week for n weeks, we don't know how many it is right now, plus 25. And it says we saved for 8 weeks, so that's what we're going to put in right here. So 4 times 8 plus 25, 4 times 8 is 32, plus 25 is 50, you would have $57. Let's see if it agrees with me. Yep, we'll just have that in a different order, which doesn't matter. $57. So that's it for 1.3. Go do your assignment, and we'll see you next time.